Hello, applied geometry. This is your lesson on arcs and chords. Okay, so by considering that you're watching, I'm figuring that you probably got logged in. I'm hoping you have a packet in front of you. Please remember to fill out that packet completely as you're going through, and then turn it in at the end of the hour for your to get your credit for today. Okay, and I will get these back to you so you can keep them for your notes. Okay. So first thing up, this little bell ringer. Okay. So go ahead, do this either on your bell ringer sheet or do it in the packet. Either way, I'll see it and give you your bell ringer credit for the week. Okay. The joy of having a YouTube video is that you can watch it, pause it, and then go and do things and then come back to it. So here's what I'm going to ask you to do. Pause the video right now. Go ahead and do the bell ringer and then come back and see the answers. All right. So pause. All right, so here's the answers. So to find the measure of angle A, okay, so this was a scenario that we had set up where we know that these angles are 90 degrees, they'll always be 90 degrees, and so that means that these opposite angles are going to have to add up to be 180, okay? So if you do 180 minus 39, it gives you 141. So that will be the measure of angle A right there, okay? For this scenario over here, okay, you know that all of these segments are going to have to be congruent to each other because they're all tangents of the circles, okay? So you can set it up such that 2x plus 4 equals 5x minus 5, and then we solve. So subtract 2x from both sides, it gives me 4 equals 3x minus 5, and then add 5 to both sides, and this will give you 9, and then divide both sides by 3, and this gives me x equals 3. But remember, you're not done yet. I wanted the measure of SB, so I actually have to plug the 3 back in. So either one will work. So 2 times 3 plus 4, 2 times 3 is 6, plus 4 is 10. So the measure of this segment is 10, this segment is 10, this segment is 10. Of course, this was the one you were trying to find. Okay? All right. Okay, so by the end of today, you should be able to calculate arcs and angles if I give you some variety of situation, okay? So I could either give you an arc and you tell me what the measure of the angle is or vice versa, okay? And the reason why you'll be able to do this is because of the relationship between arcs and angles, okay? So first of all, what is an arc? So an arc is a length along the circle, okay? So if you're looking at my circle over here, so I can pick any 2 points. So let's say I pick this point and this point, this would be J, and maybe this is K, okay? If I go along the circle between J and K, that is an arc, okay? And I name those with a little half circle on top of them. So I would name that arc JK with a little arc above them, okay? Now a central angle, think central, center, okay? So it's an angle that sits at the center of the circle. So it's an angle whose vertex is at the center of the circle. Okay, so like the central angle for this arc would be, there's my center. So I would draw in this angle here, and maybe I name this L. So that the angle JLK would be my central angle, okay? Notice the central angle matches up with the arc, okay? So central angles intersect is our word that we use, an arc. And the relationship between them is really, really nice, okay? The measure of a central angle always equals the measure of the arc that it bites off, okay? Always. It's really cool. You'll see why here in a second, okay? Now, just so you know, some differences here. There's major arcs, minor arcs, and semicircles, okay? So think minor arc, it's a little arc, and so it's going to be less than 180 degrees. So like this arc right here, I'll go to A and B. So that arc AB would be a minor arc. It's less than 180. Remember that circles are 360 degrees, so a half of 360 would be 180, so it's less than half the circle, okay? So the way that we name those is just like I was showing you. So this arc between A and B would be arc AB with a little thing over it, okay? Now, however, if I want a major arc, think more, it's more than 180 degrees. So to name these, we actually have to tell ourselves that we want to go the other way around the circle. And so the way we do that is I pick a point over here, I'll name it C. And so the major arc would be from A going all the way through C and coming back to B. That would be the major arc between A and B, okay? And so the way I name it is I say, well, I started at A, I I wanted to go through C, and then I ended at B. So that's arc ACB. That's how I name a major arc. Okay? Now a semicircle. Semicircles are half of the circle, so they are exactly 180 degrees. And they're formed by a diameter, because the diameter bites off half the circle. So if I have my diameter here, goes to the center of the circle, that means that this, in pink there, that's a semicircle. It's half the circle. Okay? All right, so here's where it comes into play, okay? Because I told you that, remember that the central angle is equal to that measure of the arc that it bites off. Okay, so here's where it comes into handy, because I want to know what is the measure of this little angle in there. Well, it just so turns out that since this arc is 120 degrees, this central angle that forms that arc is also going to be 120 degrees. Okay, and so you can even do that for this one up here. So since this arc is 155 degrees, that means that this angle in here is also 155 degrees. Okay, let's try another one. So like this one right here, okay, so this arc is 50 degrees. So what would be the measure of this angle in here? It would be 50 degrees. Very nice. Okay. All right, I'll let you answer this one. What do you think? What would be the measure of this arc here? I'll notice that this central angle right here is 128 degrees. So that means this one would be 128. Okay. And notice here, this angle is 123. So what do you think that arc is? Very good, 123 degrees. Pretty straightforward, right? Okay, let's have a little bit more fun with it, shall we? Okay, so now I want arc CFD. Okay, so remember that that's a major arc. It means I'm starting at C. I'm wanting to go this way around the circle so I can get to F, and then I'm going to end at D. So I'm looking for this arc right here. Now the measure of that arc is going to be equal to the angle that goes all the way from here to here. Okay? Well, if I want all of that angle, notice I know part of it. I know this part's 135. I know that this part is 81. So the question is, can I figure out the rest of it? Okay? So, well, looky here. I know that this right here, this is a straight line, isn't it? A straight line is 180 degrees. So if I do 180 minus 135, that gives me 45 degrees. So this angle right here is 45 degrees. Okay. And notice this angle is right across from this angle. And it's a vertical angle because this is a straight line, this is a straight line. So if this one's 45, this one's also 45. And hey, now I know all the angles around here, I can just add them up. So 81 plus 45 plus 135 plus 45. Let's add those up. So 5 plus 5 is 10, plus 5 is 15, plus 1 is 6. Carry the 1. 4 plus 3 is 7, plus 4 is 11, plus 8 is 19, plus 1 is 20. 306. So if the angle is 306 degrees, then also the arc is 306 degrees. What about this one? So this one, I want the arc SVT. So it starts at S, it needs to go this way around the circle so we can go through B, and it ends at T. I know that, so I'm looking basically from this angle all the way around here. So I know that this part of it's 50. Ooh, and notice I have another straight line going on, right? So I could do 180 minus 50. That would give me 130. So that means this angle right here is 130. And these are another pair of vertical angles, aren't they? So if this one's 130, then this one is also 130 degrees. So now I can add them all up and find out the measure of my arc. So 5 plus 3 is 8, plus 3 is 11, carry 1, so it's 310 degrees for your arc. All right, now I need arc JKI. So starts at J, goes all the way through K, comes around here, ends at I. Okay, so basically I need from this angle all the way around to there. Well, I know this part's 95 degrees. Ooh, looky here. And I have a straight line here. So this is half the circle, isn't it? Well, how much is half the circle? 180 degrees. So I could add 180 and 95. So that would be 175 degrees for your arc. Okay, so pretty straightforward. A lot of these will use either vertical angles, knowing that half the circle is 180 degrees, and that straight line is 180 degrees. Okay, and knowing that a whole circle is 360. Okay, so angles work pretty much the same way. Okay, so let's say I wanted angle SPQ. So SPQ, that would be this angle right here. So that means I need to know something about this angle, and this angle. Okay. Well, I know this angle is 86 degrees because look right there, there's its arc. That's also 86 degrees. I know that these two angles are congruent, which is nice, okay, but I need to figure them out. Well, notice that I know that this arc is 86, this arc is 154, this arc is 60, and then I just don't know this last part of it, but that completes the circle, right? Well, a whole circle is 360 degrees, right? So what if I added these all up? So 86 plus 154 plus 60. Okay, so that'll be 9 plus 4, 300. And so 360 minus 300, 60 degrees. So that means this arc from here to here is 60 degrees total, which is fine because we need to know both of those angles, right? So both these angles together make 60 degrees. And hey, look at it. Now we have everything that we need. 86 plus 60 gives us 146 for that angle. Not too bad. All right, what about this one? So I need angle QPS. Angle QPS, like that. Okay? Well, I know this angle's 40. Ooh, looky here. I have some vertical angles going on right here. So this angle is 80. This angle would also be 80 degrees. So I can do 80 plus 40 gives me 120. Yay! All right, this one. Angle KLJ, right there. So I need this angle. I know this angle is 65 degrees. So are these two vertical angles? Yeah, they're formed by straight lines that intersect. So if this one's 65, this one's also 65. So 65 degrees. All right, we're going to skip that one for right now. Okay. You can also solve for x. So this one is kind of an interesting situation because you're used to seeing boxes in here when they're 90 degrees. But notice you can note that these are still 90 degrees anyways because here's the diameter, so you know it's 180 degrees. And you know these two angles are congruent, so you know that they're the same. So if I cut 180 in half, that means this would have to be 90 degrees, which means that that arc is also going to have to be 90 degrees. So you have x plus 93 equals 90. Go ahead and solve that. So that gives you x equals negative 3. Pretty cool. Try another one. Okay. So for this one, actually, we're running out of time. Skip that. So there's a couple of problems like this on the worksheet on the back of your packet. I'd like you to try them at least. Okay, see if you can figure them out, and then we'll talk about them more when I return. Okay. Just so you know, it does make sense. Congruent arcs, or I'm sorry, congruent chords have congruent arcs and congruent central angles. So basically, if they're congruent, they're congruent, they're congruent. Okay? So you can see here you have some congruent, you have some arcs or chords right here, and they're congruent. So that means that these angles right here would also be congruent, which means that these arcs out here would also be congruent. Okay, basically that just lets you do a little bit of algebra. Okay, so like for this one, okay, if I say that AB bisects this angle right here, that means that these two angles are congruent, which means that these two arcs must also be congruent. So you could set up 6x equals 20 minus 4x, and then go ahead and solve for your x. Okay, so please complete the practice worksheet at the end of your packet. Remember, it is due by the end of the hour. You may ask the sub for some help, and we will talk when I return. Have a fabulous day.